Okay, for number 1 in our homework, this is where we needed to plug in all of these different values and see what was going on the interval from -1 to 2. And so I'm going to go ahead and just write in our different values that we had. And so a lot of times on the AP exam, you will already have all of this information given to you, and it's just a matter of being able to read the chart and tell where your values have to be. Also, it is important while you're reading through the information that you realize that the function that you're working with is continuous. That's always important. And now with the intermediate value theorem, we see that our two endpoints they're not the same. And so we're looking for a value so that we're looking for a solution. Okay, sorry. I was looking for what it was asking for, and it was right there in front of me. So I need to know, well, where does f at x equal 0? Or really, does there exist a c value so that f at c equals 0? That's really what it's asking for. And so we see that that solution must lie inside that interval because we have a sign change in our y's. Our y's changed from negative to a positive. So our solution here, since again we are continuous, and so our solution is on the interval. So let's write that up. The solution occurs on the interval from 1.3 to 1.4. Okay, on number 2, we are asked to find the value c, so that, or the value c guaranteed by the intermediate value theorem over this interval. We do see that f of x is a polynomial, so that means f of x is continuous. And so that's always something you need to note. And then the next thing, you need to check your endpoints to see their value. Well, f at 0 should be negative 13, and f at 4 is 19. And so we see that f at c is between f at 0 and f at 4. So we know we are guaranteed the c value. So what I need to do is sub in c for x and set the function equal to 8. So I have 8 equals, and let's see, I'm going to have c squared, find my function again, plus 4c, and that's minus 13. There we go. And so we do need to set this up for factoring, so I'm going to subtract 8 over, and that's going to give me negative 21. And so when I factor this, I do have a positive 7, I have a negative 3, and now when I solve for c, I have negative 7, and c is 3. However, negative 7 is not on the interval from 0 to 4, so that c value gets tossed. And so we have a c value of 3. Okay, now the next problem, it says show that Judex has a root somewhere over the interval from -1 to 2. So what that means is if g of x has a root somewhere, that means that there's some c value so that g at c equals 0. That's what it means. Again, we need to make sure we illustrate that we know g of x is continuous. That is important for us to show. And then the next thing, we need to check our endpoints and see what their values are. So g at -1 is going to be 8, and g at 2 is negative 19. So notice this g at c value is between g at -1 and g at c is less than g at 2. So there should be a value there that does end up giving us our 0. So here we have everything stated, and so we can say by the mean or by the intermediate value theorem, there must be a C value on this interval from -1 to 2 so that G at that C value is 0. This problem is a multiple choice, and it's asking us between which two values does this equation have a solution. So we're looking to see where we would end up with a 0 here. So I'm going to call this function f of x, and f of x, I'm going to go ahead and label that 3x cubed plus 5x minus 11. And I'm also going to state that f of x is continuous because, again, we have a polynomial. And now we're going to go through and let's see, f at, well, we need to pick an endpoint, don't we? And so it doesn't really matter which one you start with. I will choose f at, it looks like maybe a -1. We could choose, let's start with C, f at -1. Well, if I plug in f at -1, I'm going to get -19. And if I plug in f at 0, that means I get -11. I don't have a sign change, no sign change. So we can't have that because the solution's got to exist where I have a sign change. So let's try B. So C's out. Let's try B. And I'm just picking the first answer choices with a 0 because I'm lazy. So f at 0 is -11. And let's find f at 1. F at 1 is going to be -3. Oh, no sign change there. So that one's out. So let's try D. So let's keep up with where our answers were. That was C, that was D, or no, that was B, sorry. My crack's kicking. All right, so D. So again, I know what f at 1 is. F at 1 was -3. Now let's find f at 2, and that's going to be 23. So yay, I have a sign change. So I know there has to be a y value of 0 between a positive and negative. So that's going to be answer choice D. All right, so for number 5, notice that we're asked along the same lines, determine on which intervals satisfies the conditions of the intermediate value theorem for f of x equals 0. So it's important to note here that our f of x, we can't just assume it is continuous anymore because we have a rational function. And with rational functions, we run the chance of having a vertical asymptote and or a hole in the graph. So notice that we have a denominator here, and I need to set that denominator equal to 0 and solve so that I see where I'm going to have a vertical asymptote. And let's see, that's going to occur at 2.5. So we need to know that we have a vertical asymptote here. So that's going to mean that my function is not continuous. Asymptote. I can't spell today, folks. Asymptote. There we go. We need to know that we're not continuous at 2.5. So automatically looking at your answer choices, you need to omit the intervals that would contain 2.5. So those intervals that would contain 2.5 would be C, and it would be D. So that gives us a 50-50 shot, and just knowing that we're looking for that interval that we are continuous on. Okay, so now we're left with either A or B. Notice the common number in A and B is 1. So let's go ahead and find 1. So I'm going to sub into my function here and find f at 1. Well, f at 1, if I sub in 1, that's going to give me a negative 1 over a negative 3, which is a positive 1/3. Now let's try f at 0 and see if it's answer choice A. Well, very quickly we can see if I sub in a 0, I have negative 3 over negative 5. Notice there's no sign change there. So I know it cannot be A, so that leaves my answer choice to be B. Okay, moving on, apply the intermediate value theorem. So that f at c equals 9 for the function of whatever we're given here. So we have to just say that that c value exists. That's what we're trying to prove. So looking at our function here, we do have a polynomial, so that's going to be nice. So here we know f at x, well, help if the pen would write. We know that f of x is continuous. That's important. Okay, now the next thing, we need to check the value for f at 1. Well, f at 1 looks like that's going to generate a 2. And then f at 2, that's going to be 8 plus 2, which is 10. Okay, so notice that we're looking for whether or not f at c equals 9 is a possibility, and it is. And we're going to go ahead and list that f at 1 is less than f at c, and that in turn is less than f at 2. So with f of x being continuous and this part of it, so we're going to have that same, and we can just build on that. So by the intermediate value theorem, there exists a c on the interval 1 to 2, so that, and you just state that conclusion, which you're getting it from up here, so that f at c equals 9. Okay, so we have a delivery van, and notice up here we're told that this velocity in feet per second is a continuous function. Okay, so we automatically know then that we can start trying to apply our intermediate value theorem. And here's something we need to know: if the van must be stopped, that means that my velocity equals 0. So let's go ahead and start this. We know that our function v at t is continuous. Okay, and so it looks like we would have 3 stops because we're looking where we had sign changes of our y values. So we have 3 stops here. So we're going to say the van stops at least 3 times. And we need to list the intervals. So let's see, on those intervals, and I would just note the signs here. So on the interval from 7 to 12, we see that v at 7 is negative and v at 12 is positive. So by the intermediate value theorem, v at some c has to be 0. And then it's going to happen again over the interval from 18 to 22. And again, we're going to say v at 18 is greater than 0, and v at 22 is less than 0. So by the intermediate value theorem, there has to be a v at c so that we have 0. And then we're going to repeat the same thing for the interval from 22 to 30. And again, I would note those signs. V at 22 is less than 0, and v at 30 is greater than 0. So by the intermediate value theorem, there has to be a v at c equal to 0. All right, so the next problem we have, number 8, is asking us to explain why the intermediate value theorem does not apply here. So we do see that we are continuous, so it's not a continuity issue. So we need to look over at our endpoints, and we see that v at 0 is 5, and we see that f at 6 is 53. So notice we had no sign changes here. So let's see, it looks like goodness. So f of x is positive, is greater than 0 over this interval. And therefore has no zeros. A lot of writing with this. All right, so for the next one, we are looking at a composite function, h at x, and we're trying to show that there's a c value so that h at c is -2. So we see that f and g are continuous. So h at x is also continuous. Okay, and now we need to check our endpoints here. So we need to look at h at 1, which is going to be f of g of 1, and then -1. And you go through and read your chart. So g at 1 is going to be 4. And so now f at 4 is going to be -3. So -3 minus 1 is -4. And now let's look at h at 5. So that's f of g of 5 minus 5. And so that's going to turn into f at, and so g at 5 is 3. And then we have to find f at 3, and f at 3 is 7. And so we get a 2 here. So notice that we are continuous, and -2 is between our two endpoints, so we have to have a c that's between 1 and 5. So let's write that up. We see that h at 1 is less than h at c, and that's less than h at 5. So by the intermediate value theorem, there must be a c. And then let's see, I guess I need to make that c. There must be a c on the interval from 1 to 5. And so that h at c equals -2. All right, so let's move on to the next one. Again, same idea, but this time we're going to have to actually find the value of c, so yay. All right, so we do need to check here. We do not have a continuous function. Notice we have a rational, and so we need to set that denominator equal to 0. And so that tells me I have a vertical asymptote at x equals 3. Now, 3 is not over this interval, so it's okay to go ahead and say that f of x is continuous over the interval -2 to 2. And then we need to check the value of f at -2. And so that's going to be -2 over -5, so positive 2/5. And we need to check f at +2, which is going to be 2 over -1. So I have -2. So it's safe to say that 1/3 is between those two. So we're going to say f at 2 is less than f at c, and that's going to be less than f at -2. So by the intermediate value theorem, there must be a c inside the interval -2 to 2, so that f at c equals 1/3. Now the next part here, they want us to go ahead and find that. So we are going to find f at c. So f at c is 1/3, so I'm going to have 1/3 equals, and I am plugging in a c value, so I'm going to have c over x, not x, goodness, c minus 3. You can do your cross multiplication, so c minus 3 is 3c. So -3 equals 2c. So here, -3 halves, that's equal to c. So here we have found that c value, and we have justified why it must exist. Okay, for this one, we have to show that there is a value c inside this interval so that this happens. So keep in mind our function's right here, and we are continuous, and so I can go ahead and label our function. I'm going to label this f at x. It's going to be x squared plus cosine of pi x, and I'm going to try to find my endpoint value. So f at 0 is going to be 0 squared plus cosine of pi times 0, which is just 0. So that's going to give me cosine of 0, which is 1. And then we need to find f at 2, so I'm going to have 2 squared plus cosine of pi times 2. And so that's going to be 4 plus 1, which is 5. So notice this 4 is between 1 and 5. So, and we're not going to actually find the value of c. That's not going to be something we do right now. So let's go through and state why there must be that value. So we notice that f of x is continuous. And we also see that f at 0 is less than 4, and that's less than f at 2. So again, by the intermediate value theorem, there must exist a c on this interval from 0, it was open this time, from 0 to 2, so that our function itself equals 4. Okay, so for number 12, again, looking at this, we have a rational function, so I need to check where we are not continuous, and that's going to be at x equals 2, which is not over the interval that we given. So we can say h of x is continuous on the interval from 2.5 to 5. Okay, so now let's go check our endpoints. So I need to find h at 2.5. So that's going to be 2.5 squared plus 2.5. I don't know why I put parentheses there, all over 0.5. And when we work that out, it looks like you're going to get 17.5. And then we need to do h at 5. And so we're going to have 5 squared plus 5 all over 3. And when you work that out, you're going to get 10. Okay, and so notice that 12 is between these two. So we have h at 2.5. Nope, we need to do h at 5 first. Sorry. So h at 5 is less than h at c. And then that's less than h at 2.5. So there must be a C on the interval from 2.5 to 5, so that, and we have H at C equals 12. Okay, now they told us to find that C value. So we're going to come over here to the side, and H at C is 12, so I'm going to have 12 equals, and that's going to be C squared plus C over C minus 2. And again, I would put that 12 over 1 and solve it like a ratio. So we're going to cross multiply here. And so when I do, I have 12C minus 24 equals C squared plus C. Move everything over and factor, so I'm going to have 0 equals C squared minus 11C plus 24. And then that's going to factor into negative 8, negative 3. And so I have two C values that will satisfy this. However, only one of those would be inside this interval. So we're going to have to toss the 8. All right, last problem on this homework assignment. Again, same process. Does the intermediate value theorem apply to this function on the interval from 2 to 5? Now you have an exponential function, and exponential functions are continuous everywhere. Okay, so let's go ahead and find what is the value for f at 2. So f at 2 is going to be negative 1/2 raised to the first minus 3. So that's going to give me negative 3.5. And for our other interval, let's see, we're going to look at f at 5. So that's going to be negative, and then 1/2 raised to the negative 2, and then minus 3. So that negative exponent means reciprocal, so that's really going to be a 4, and then this negative out here is going to make that negative 4, then minus 3. So I'm going to have a negative 7. And so very quickly, let's see, we're trying to prove this negative 4. So we see that f at 5 is less than f at C, and that's going to be less than f at 2. And so let's see. So by the intermediate value theorem, there must be a C inside the interval from 2 to 5, so that f at C is negative 4.